All right, hello everybody, and welcome to our second office hours on Getting Started with Digits. Just like last time, we're going to be doing most of our Q&A through the chat window. Also, in addition, Allison Gray will be going verbally over some common questions and some high-value questions we got last week and over the course of this previous week while people worked on the labs. So please ask your questions in chat. We have a number of experts online who will then answer them. We're also going to record and make all these questions and answers available on the Deep Learning course page. So please check back in a day or so, and they'll be there in a PDF with all the questions and answers. We did this last week, and we'll do this again this week. Please answer your questions, and then we will try to get to them answered as fast as we can. We will make sure everybody can see both the question and the answer when we respond. So, Allison, go ahead. Allison, you there? You might be muted.
Oh, there we go. Hi, everyone. Thanks for participating today in our Q&A session. I hope you guys all enjoyed the last session we had where I gave the introduction to digits, and I hope you were all able to get started and complete the hands-on lab. So I'm just going to answer a couple questions that we have today, and then as you have more questions, please post them, like Mark said, and we'll work on answering them through the chat, and I'll try and answer some of them verbally as well. So to get started, I'm going to start out with a couple questions on just how to configure and things that you can do with digits. So one question that someone had last week was, do we have any recommendations for an EC2 instance suitable for digits? And if you go onto AWS and you log on, there are a variety of different instance types and there are GPU instances. So if you're interested in a single GPU instance, you can configure digits on a single GPU instance, and it'll be titled a G2 2x large. And there's also a 4 GPU instance, which was recently added, I think a couple of months ago, the G2 X large, and it's really great. I've tested out the multi-GPU digits on the 4 GPU instance, and it works out really well. So definitely give that a try if you'd like to do things on AWS. As far as other cloud providers go, you might want to check out SoftLayer. So, SoftLayer also offers GPU instances, and you can set up your instance by the hour or do monthly there as well. And they have different GPUs. They have a K80 GPU, which is our fastest server GPU, and you can definitely look them up and check that out and configure digits on there. So another question, so if you don't have a GPU available or you don't have a system available, definitely try AWS or SoftLayer. That's another way to just get started with digits. As far as whether or not digits will work without a GPU, you can use digits in just CPU mode. The only thing with that is that digits works with Caffe, and so when you rebuild, you'll have to rebuild Caffe or build Caffe, and when you do that, you'll build it with the CPU-only mode, CPU-only flag enabled. Someone also asked a quick question about cuDNN. So cuDNN is a library that NVIDIA came out with, and it gives you extra performance during training, so your trainings will go even faster. And that's a free library you can download off of our website, and the advantage there is you get extra speed, extra performance, so you'll train even faster. And it's free. It's easy to download. It only works with GPUs. It uses CUDA. And one thing to keep in mind there is that if it only works with GPUs with compute capabilities 3.0 or greater. And you can look on our website to find a list of GPUs that have 3.0 compute capability or greater. But if you guys are looking at maybe getting a Titan X or a GTX 980, those are all encompassed in that. But you can always double check the website too. So if you have a system with a GPU that you bought maybe a year or two ago or some time ago, you can check the list and see what the compute capability is for your GPU. There were a couple questions before about Windows as well. So there are a couple ways to do it. If you're interested in using digits on Windows, there's been some activity online about people doing it. The first thing that you'll have to do if you want to use digits on Windows is you'll have to build Café. So just remember to download the NVIDIA branch of Café, and then you can build it through Windows. And there's a couple blogs online about it too, where people have gone through the process step by step. It's a little bit more, there are a few more steps. It's a little bit more of an involved process relative to doing it on Linux, but it can be done. And then if you run into questions or have hiccups, you can definitely reach out to us on our Digits Google user group. And let me get to that slide just so everybody can kind of see it here, so everybody knows what their resources are for using Digits. If you have questions for using Digits, and you can reach out to us. And there are plenty of links. If you go to our Digits users Google group, you'll find information on questions people have had for setting up Digits and getting started. And you'll also see information on issues people have had, how they've got things set up on Windows, and then we can engage with you directly there as well. So it can be done on Windows, but you'll have to do a little bit more. We don't have a web installer ready, but you can, based on what I've seen on activity on the internet, it looks like it can be done. I haven't tested it myself though. So a couple other questions that I thought I'd would answer because of some of the questions. For those of you that have participated in the lab already, you had some questions about doing parallel paths in the neural network, and some people were asking about how to do that and is it possible. One thing to look at when you launch Digits is the standard networks. Take a look at the GoogleNet network. There is, you can see how they've managed data between layers and so forth. In the lab, on the hands-on lab, I did not set things up that way. You're just going to push all your data through each step of the layer. So all the data will get pushed through the convolutional layer. All the data after that will be pooled, and then all that data will go through an rectified linear unit activation. And then it will go through another convolution, and then maybe it will be normalized. But I have it set up like that. But if you are interested in how you can do other things, then you should check out the GoogleNet network. And it's a standard network. And you can visualize it, and you can check it out in the Customize window. And it will show you how they've laid out the data. And then when you go into the Customize window, you can see how they've parsed up the data, how they separated things, and see all the functions that they've used. For the hands-on lab, I didn't go through that process just because my goal here was to help everybody get started with Digits and help you, just give you some ideas on ways to start experimenting. Things that I did when I first started using Digits and trying to modify my network. And the whole goal with that was just to say, okay, if we make these simple modifications or small changes in my network, how does that impact the performance of my network? Am I able to classify new images? And when I was making the lab, I spent some time finding images that would work with these small modifications, and the network would suddenly be able to classify correctly. And that was the whole goal. But definitely when you have your own data, you may find that making some of those small modifications work for you, and sometimes they don't. There's a lot of knobs to turn, and there are a lot of ways to modify and improve your network. And the whole intention with this lab, once again, was just to give you an idea for how you can use Digits to help you do that and help you explore different network configurations with your data. There was also a mention about what rectified linear units are. And you can check that out online. It's really interesting. So I first read about it with the 2012 ImageNet. There's a competition called ImageNet, and the winner of the ImageNet competition in 2012 used it, and he published a paper on it. And I think I talked about ImageNet earlier in this presentation, but it's an annual competition where teams compete to develop the most accurate classifier, and they're given 1.2 million images. And in 2012, the winner used rectified linear units, and it was the first time I had read about it. And he found that he was able to train more quickly and with his data when he did it, and you can check it out. One thing about what it does is, so if your outputs are less than 0, then it's 0, and then if it's above that, then it's essentially your output is what it is, right? And then there's there's a great Wikipedia page on it, and that I would encourage everybody to check out. and my apologies for not having a slide here to go over that in detail. But when I first read about it, I read about it in a paper on the ImageNet 2012 paper by Alex Krivetsky, and then I just checked out the Wikipedia page. There's great documentation and information there on that, and it compares. That's an activation function. That's one activation function. And as you're going through this process of using digits, you'll learn that, and even just in general with using neural networks, you'll learn that there are other activation functions too, such as the sigmoid function or the hyperbolic tangent. And I would definitely encourage you to experiment and try those out and see for yourself what the changes are in performance given your data set. So if your images have different sizes, there was another question about whether or not your images, if your images are different sizes before you put them in and input them into your data or input them into digits, digits can handle all that resizing for you. Yeah, so when you go to the Create Your Dataset page, and I'll go to that link for you, or I'll go to that slide so everybody can see it. So when you go to that, you'll put in the path. You'll go to this page. It will look just like this. You'll enter the path to where your images are, and even if they are not the same size, that's totally fine. Digits can handle all of your resizing for you. One thing to keep in mind, the examples that we have in the hands-on lab is that have all the images being square, but you can definitely do things. You can make things rectangular. You could have like a 512 by 256 or a 256 by 512 or something like that. There were a lot of questions on if you can put in other types of data. So right now, digits will ingest only image data. However, if you have, let's say you have some type of signal or input data, and maybe it's just a linear string or a linear array, and it's 1 by 100 or 1 by 500, you can input that into digits as well. You're just going to specify that in the image size here on this screen. So you would just put a 1 in and a 256 or a 1 in by whatever dimension you have. So somebody also asked, I mentioned cuDNN earlier, but someone was asking what the difference is between cuDNN and Caffe. And one thing to keep in mind, cuDNN is a library, and then Caffe is a framework, and then Digits is your interactive tool that sits on top of it. So cuDNN, when you get your system, you install your GPUs, you're going to install your driver, and you're going to install CUDA. cuDNN is another library that uses the GPU. It has calls for and it has calls specifically for accelerating the whole process of deep neural network training and speeding up that process. And then on top of that sits Caffe, and Caffe is your framework, and it will call those functions and use those to help accelerate the whole training and the classification process for you. And then on top of Caffe sits Digits, and Digits is think of Digits as your interactive tool. You're developing a deep neural network for your data set, but you're not doing any coding. You're just interacting with this graphical user interface. It's allowing you to do image resizing here with just a few clicks. You're just typing in the size that you want of your images before they're ingested in the network. You're just typing in the path to where your data is. And when it comes time to training, you're selecting a network and you're editing essentially your network file when you want to customize and modifying that. So there was another question about how is the performance of deep learning with imbalanced data? So it's comparable to any other machine learning technique. If you have balanced data, and that means that if you have balanced data with respect to your categories. So if I had maybe 100,000 images and I was going to push them through Digits and I had only 2 categories, and I put them in 2 categories, and maybe 90% of that data is images of people, and then the other 10% were images of dogs. And then when I did my training, I found that I had an accuracy of 90%. But then when I looked at individual, when I did some spot checking and tried to do classification of individual images, I found that, oh, I've got 90%, but I'm really only classifying that first category effectively. I'm not really classifying the images or data, anything from my second category that only represents 10% of my data set. So those are just two things to think about. You want to have kind of a balanced data set, balanced input data to train on too. A couple other questions. I had another question about customizing your network. Somebody had mentioned something in a question where they said that they were unable to continue editing the same custom network. So if you go to, when you go to your creating a neural network, so what happens if you've already completed the lab, you're familiar with this interface, but you'll be able to select your network in a standard network and you customize it. If you go to previous networks, you'll see all the networks you've created. Be sure to select it. If you select it, then you'll see this customize option appear. And then from there, you can start editing your network that you've recently created. So another thing that you can do, if you want to experiment with pre-training, since I'm talking about it here, if you wanted to load a pre-trained network that you created yourself, you can do that through the previous networks as well. So that's just a couple things to think about. So hopefully if you want to go back and redo the lab and test that out, definitely do that. If you're getting ready to configure your own system with digits, that's how, now you know how you can do that. There was a couple questions about Red Hat releases as far as building on digits. And sure, you can, of course. You just have to build Café from source. So a couple things to keep in mind I mentioned earlier, but just to remind you guys, when you want to build Café from source, there's two ways to get it. If you download the web installer, it's made for, it's been precompiled for Ubuntu, so you just have to rebuild it. Or you can go to the NVIDIA GitHub site and you can download the Café version, NVIDIA's Café version there. And here's a link to it. So just keep in mind that yes, you can do it on Red Hat. It will work. Just use this link to get our NVIDIA branch. And when you download that branch, you can go into the makefile, and if you're using cuDNN, enable it. And of course, if you don't have a GPU and you don't have then you can still use the same branch, and you can uncomment the CPU only flag and still use digits and Café on your machine. But here's how you can get it. And then just a reminder about the GPU capabilities for cuDNN. Your GPU should have a compute capability greater than or equal to 3.0. For those of you that may have memory issues, you probably didn't experience this in the hands-on lab, but you may encounter this if you're using things on AWS. One thing to keep in mind when you start training and experimenting with your network and configuring things, if you have a memory allocation error or you get into a memory error, just try reducing your batch size. And the option is right here in your solver options. So that's just one thing to keep in mind, especially if you're going to go on AWS and you're going to train with GoogleNet. If you train with AlexNet on AWS, you can have a batch size of roughly 128, I think. But if you go to GoogleNet, you'll probably need to reduce your batch size to about 24. So if you have any memory issues, or maybe you're on an older GPU and you have less memory and you run into these issues, just remember to change your batch size. That's one thing that's usually the first thing I do. I try. There were a lot of questions about classification. So right now, if you use digits, digits supports classification. If you wanted to do other things with digits and import that, you can definitely do that. If you want to take like your network file, let's say you're using Café and you want to extract specific features, you can definitely do that with your trained network like you would through the Café framework. But right now, if you want to use digits. Right now it's currently just supporting classification. There is some work, and you can definitely check us out online at our GitHub site. There is some work going on for supporting other types of things, like non-inference types of stuff. And definitely check it out online, our GitHub and our pull request to see activity and see things that we're doing in the future. Also, if there are other things that you're interested in seeing, a lot of people ask about if it's just classification or are there other things I can do with digits, other types of things like localization. Just engage with us on the Google users group, but you can also engage with us on our GitHub too and ask us questions. We've got a lot of requests going on, so you can also just peruse it and see what activity, what we're planning to implement, what's going on in the future, and things like that. Someone was also asking about classifying if they have 30,000 images, would they recommend using digits? So if I had that many images, so when I'm using digits, I think of digits as my interactive tool for developing my deep neural network, and when I'm doing classification, I'll take part of my validation file and I'll classify just to look at things individually. Or maybe I'll have a series of images that I'm really interested in creating a deep neural network for. And so after I'm done training, I'll push just those images through digits for classification and classify. But when I have like 30,000 images, I'd rather have just like a simple Python script that uploads my neural network, or that reads in my network configuration and then reads in some text file with my images and then just does classification. And then I would do that just so I can see, okay, what my overall accuracy is, and I would just have it output a simple number. And then if you were interested in this large data set of images, large set of images that your network hasn't seen, if you're interested in knowing what the accuracy is per category, then I would just write something in for that too. So that's the way I would take the approach. If I had 30,000 images that were not part of my training set at all, and I just wanted to see how well my network could classify them, I would just download my trained network from digits and then write a little Python script. As far as doing that goes, if you want some help getting started, we have an example script now in digits that you can download and test out, and you can use that as a starting point for doing classification, and you can just build on that and change that so you can do batch processing. I also noticed that through Caffe, there's also a C++ example for classification too. So if you want to use that, definitely check that out as well. Somebody was asking another question about, is it possible to achieve good results on mid-end GPUs using digits? Sure it is. GPUs accelerate your training, right? And so that's what's so great about a GPU. The only thing you have to watch out for is memory. So if you don't have a lot of memory on your GPU, you can still train, you can still get a lot of speed, but just think about reducing your batch size if you hit memory issues, memory errors. I've got a lot of questions on, somebody asked about digits, the digits license. So if you go on the GitHub site, you'll see a clause in there that fully describes our licensing agreement and that it's open source and that anyone can use it. And just remember for classification, because I see a lot of activity on that, don't worry. It's for classification, and then if you have a rectangular image, we can definitely ingest that. And if you have a signal or an input data that can be put into a linear array, we can still ingest that. When you train with that type of data, digits will still try and push it through as an image, but don't worry, it's still classifying that data and it's still pushing it through the network, and your results should be fine. Someone also asked about can digits recognize and run on a consumer GPU, say a GeForce GTX 980? Of course it can. You can still use it there. And as far as GeForce goes, it's great. GeForce cards, they're really easy to get. They're great for development. But when you start thinking about getting into a deployment scenario and putting things in servers, you want to start thinking about, we recommend using our professional cards, like the Tesla line. Those are certified for running in a server, and they're designed for that type of environment. So those are just things to think about as you go through the whole process of developing a deep neural network for your data, and then you want to deploy it, and then you want to deploy it maybe in a server or a cloud-like environment, and you're going to have this yourself. Think about using Tesla. There are a lot of advantages to to having a certified setup, a certified configuration when you're in that type of environment. As far as other environments go, somebody had asked a couple questions about using the Jetson TK1, and you can use the Jetson I use the Jetson TK1 for my classification. I haven't tried building it on the Jetson, but I did get some user feedback from folks online on the Google group where people are running the Jetson TK1 with digits. One thing to keep in mind with the Jetson TK1 and training is that you've got 2 gigabytes of memory, so that's one thing to keep in mind. And that's why I haven't configured digits on it myself, just because I'll use AWS, or I'll use some other other GPU with more memory. It's just easier to do. But you can definitely try it. So when I use my Jetson TK1 with digits, what I do is I'll take my pre-trained network. I go to my configuration. Let me see if I can go to the end here so I can show you the slide just so everybody can remember. Everyone can see. So after I'm done training, when I want to deploy my neural network and I want to use it with the Jetson, I download the model I want to use, and I download which epoch I want. So one thing that's really nice about digits, you can download the epoch you want. So that means that if I overfit at epoch 30, but I had my best performance is at epoch 10, I can download it there. I'll download it. I take my trained network files. I'll copy them to my Jetson TK1, and I can perform classification there. I've done classification on an AlexNet and a GoogleNet trained network, and it seemed to work okay. And I've also tested the Caffe web demo. So what you have to do on the Jetson is you have to build Caffe. So when you download your trained network, your network files are just like your Caffe network files. So if you've already been using Caffe, you'll be really comfortable with these network files. You're familiar with what they look like and what they are. And you build Caffe on your Jetson, you download your configuration from digits, you copy it over, and then you can just do classification there. If you want to test out the web demo example, just go into the Python script and edit the path to your network, your snapshot solver file, your saved network, and your labels, and then you'll be fine. So I think someone else asked about what else can digits do, and we're expanding to do generic inference in the future. And if you take a look at digits, the digits GitHub site, if you look at pull request 189, you'll see more information on how to do that. Someone also asked about different layer types. What type of layer types are supported? So as far as what type of layer type supported, anything that's supported in Caffe is going to be supported in digits. So all of that, when you were editing your trained network, when you were editing your network configuration and making those changes, those are the same changes you would make when you just used Caffe on its own, when you configured a network file. So if you started out with Caffe and you were editing a network file, and maybe it was AlexNet, you would see all those same parameters there. What the name is for your activation function, rectified linear units, for convolution, any of those things, what pooling looks like, how you define if you're going to do max or average pooling. and all of your strides, or what your stride is, and all that information. So that's all the same. So as far as layers and support, we'll support all those. We support all those things that you've already kind of become comfortable with Caffe. You'll find here within Digits. As far as databases go, if you're interested in databases and things like that, then when Digits creates your database, it puts it in LMDB. If you're using LevelDB traditionally in Digits, you really won't notice a difference. So, or if you're using LevelDB with Caffe, that's fine too, but Digits won't create that for you here. Someone also asked about how flexible is Digits with creating your own neural network. So one thing that's nice about Digits is that through that customize window feature that I showed before, when you want to edit and customize your network here, as long as your function calls are supported, then you can just edit them here and handle that all of that on your own. You definitely don't have to start with a standard network. And you don't, if you've already trained once on Digits using a standard network and you want to do fine-tuning or load a pre-trained network, you can do that. But if you wanted to use a pre-trained network such as what's shown, if you go to Caffe's website and you look at go to their model zoo and look at some of the pre-trained networks there, like they have a pre-trained GoogleNet and they have pre-trained AlexNet that was trained on the ImageNet data from 2012. If you're interested and you want to use that and do some fine-tuning on your own, no problem. When you go to custom network, you can load your pre-trained model here, just insert the path, and then you can do fine-tuning like that. So I've got a couple more questions on here. Someone was asking about GPUs or the number of GPUs that they'll need. So you can definitely just train on one GPU to get started. I really like doing multi-GPU and seeing what type of speedups I can get, because I like to see what the difference is between using one or two. As far as different GPUs, I always find it interesting to see what type of speedups I can get if I use different GPUs too. Like the difference between, if you go into AWS and you test things out on the K520, which is the GPU that they offer, I like to test that out, and then if I can get onto SoftLayer, I'll go on there and test out and see what my speed up is. I also sometimes, when I'm trying to test out different network configurations, I like to just test out different modifications. So when I was going through the process of coming up with a lab, I was doing different little model tweaks and comparing the change in performance. And I would have the 4 GPU instance open, and I would use that example network that you noted, the example of the net network, and change my outputs, add a layer, and I would do those all in parallel. And then when they were done training, or once I had saved a couple snapshots, I would go through and then do some test classifications on images. So I find doing both those things really handy. It just depends on what I'm trying to do. Sometimes I like to do multiple trainings in parallel, and it's nice to have multiple GPUs. Other times I like to just do multiple GPU training and see what type of speedups I can get. So as far as GPU types, yeah, anything that's supported on CUDA. I haven't used a GPU older than what is posted on AWS though. So, and last time I checked Caffe, I thought Caffe worked on anything that was with, like if you went CUDA 6 or higher. So those are just a couple things to think about. But if you have any issues or further questions on specific GPU types, definitely reach out to us on the Google user group and reach out to us. Or if you give it a try and have an issue, we're definitely there to help you hash out those issues and those bugs. And just as a so if somebody was interested in doing multi-label classification, so you can do multi-label classification with digits. It just depends on how you want to set it up and what your data looks like, and it depends on how you set up your labels as far as that goes. So if I wanted to do multiple labels, then I could either set up my data such that it has multiple labels in each category, or I would have separate categories with each of those labels and that data to represent that. It just depends on what you're trying to do, but you can check all that out and use the classification tab to help you. So someone asked about Alex Kravetsky's network. And yes, so that's the AlexNet network, and that was of course, the winning network in 2012 for the ImageNet competition. And that's one of our standard networks. And then GoogleNet is from the 2014 competition. And we put those in there just because they're great starting points. So when you're testing out your data and you're starting to train, so one thing to keep in mind, or one thing that I do when I start, is I almost always just start with a standard network just to see how well things are going. AlexNet is sort of my go-to network because it's relatively quick to train on GPUs, and it's readily available. And then based on that, I decide whether or not I want to try a different network, or if I should just start tweaking and modifying that network. I did this one training, so I did a training where I had an exercise where I was trying to accurately identify 5 categories, and I was having a hard time I was getting 75% accuracy on AlexNet. And so I had started tweaking with the network, trying to modify the outputs, and I was getting up to like sometimes 3% more. So then what I did was I just tried fine-tuning, and you can definitely try that. I grabbed a pre-trained AlexNet network, and then I got 80%. And so I got an extra about 5% out of that. So there are different things you can do. And I use the AlexNet network for that. And you can load a pre-trained AlexNet network for training, and then you can also just start with the AlexNet network, standard network, and start from scratch too. There are a lot of things to do, a lot of ways to do that. There are a lot of ways to ingest your data and then modify and make a network well suited for you, simple or complicated. There's AlexNet, which is easy to modify, and then if you want to go into a higher level, just a deeper neural network, we've got GoogleNet there just to help you get started too. And that's really interesting, that network. So someone was asking about the digits interface and relationship to Caffe, and I mentioned that before. So one thing to think about with digits and this whole layering, because it gets this whole layering of hardware and software and how it interacts together. So just remember that you've got your hardware platform with GPUs in it, and you've got it configured up and running. And then you're going to install your drivers in CUDA and cuDNN if you have a supported GPU for cuDNN. And then you're going to have Caffe on top of that. That's your framework. And then you'll have digits on top of that. And digits is your interactive tool. So it's your interface. It's your user-friendly interface for developing a deep neural network. And it's an interactive tool. It's a visualization tool. So when you're training, you can see what your accuracy is. You can see what your losses are. And hopefully you can see if you're overfitting or underfitting your data. Right? It's an interactive tool to allow you, to permit you to say, okay, my trainings are going well, or no, my trainings aren't going well. And here's just an example for this. So I think of digits as my interface tool. It's my graphical user interface tool. It's where I interact with my neural network, and it tells me things like this. It tells me, hey, I overfit. So even if I train this overnight, it says, okay, I overfit at epoch 10. I know if I want to take this train network and put it on my Jetson TK1, I'm probably going to download epoch 10 because that was where my train network was performing the best. And that's how I think about digits. It's my quick visualization tool. And I can just start training, I let it run, and I come back when I'm ready, and I can still visualize what happened and see what happened. And because I've taken snapshots all along the way, and I've got the snapshots in relation to with respect to all of my plotting accuracy and performance, I can quickly go back to that network, the network I want to use, and then port that. Someone also asked a question about epochs and what that means. So epochs is the same as what you would think of it. One epoch is equivalent to ingesting all of the data through the network a single time. And so when you select your training epoch, when you select epochs or decide how many epochs you want, it just means that all your data is going to be ingested by the network 30 times. One thing to keep in mind is, and then your batch size is how many images are ingested at once. So you can have multiple batches within one epoch. So someone asked about importing a trained model into digits, and yes, definitely. And that's what I mentioned before about importing a trained model into digits. And you just put that when you go into your customized network tab. What I do is, so when I'm on AWS and I want to load a pre-trained network, or if I'm on a workstation somewhere, I download my pre-trained network to my host machine, and then I just insert my path. And then I'll just insert my path into where my pre-trained network is, or into the path to where I have my pre-trained network saved on my host machine. And it would just be right here. There's a text edit box where you just put in that path right there. And then you can test things out. And that's what I mentioned earlier when I was doing some testing with the AlexNet network and some data, and I was just comparing fine-tuned network. I was just fine-tuning to see what my changes in performance would be with using a pre-trained network relative to just starting from scratch with the AlexNet configuration. Someone asked if it's regular Caffe syntax. So as far as your editing your network goes, the syntax is the exact same. So if you've been using those prototext files, your solver prototext files, or your train validation prototext files, it's everything you've been familiar with before. It's all that notation, specifying your pooling, your max, your average, your rectified linear units, all that stuff is the same it's all just like what you become comfortable with when you use Caffe on its own. And you'll notice that when you see that here in the Custom Networks tab, you'll see that it looks just like that. So you'll be really comfortable there. There's nothing really foreign. It's just that if you haven't seen or haven't used Caffe before, then maybe it will look a little bit foreign. And what I've tried to do here in the examples and in this PowerPoint was include notation for you to help you get started. But there are a lot of different functions within Caffe. So if you're interested in seeing more, you can definitely reach out to us. But there's a lot of documentation on Caffe too. I would encourage you guys to check out the website, the Caffe website. They have a lot of really great examples to help you get started using Caffe, and they've got really good documentation as well on how to create your train val file and what that looks like when you add a layer and so forth. Someone also asked about a rest with digits, and there is one. Check out our online documentation. I didn't include anything here on this presentation only because I created this presentation. I catered it to the hands-on lab, but I gave a Digits 2 webinar a week or so, or maybe a month ago, talking about Digits 2 that goes over the API calls. But also if you go onto the website or go onto our GitHub site and just search for our API calls, you'll see that in there. You'll see how you can do gets and posts and then do classification through our API if you're interested in doing anything like that. So somebody had asked about how you can shift a particular data set from one Digits installation to another. And for the most recent digits, when I upgraded from digits 1.1 to 2, I don't think I noticed any change. If you were on an earlier version of digits, there may have been a change, but it's relatively simple to create a new data set. If you've got a specific issue, definitely reach out to us, because my most recent upgrade I didn't have to, my previously created data sets were fine. One thing I had to do though was make sure that my paths were the same. So for those of you that already have digits installed, when you run digits for the first time, or when you're running digits and using digits, it creates all these data sets for you and stores them. And it allows you to go back and forth and toggle between created data sets and trained networks. And your trained networks you can download from the trained network, from your trained network downloads page. But then for your data sets like this, it'll show you this directory, like your jobs directory where it's been storing everything. And sometimes that may change depending on how you downloaded digits and configured it. If you need to relink this, or you want it to be all the same and you want to use your old ones, one thing that I do is I go into my digits config file, and then I'll make sure the path matches where my previous digits installation is, digits installation jobs directory is. So that's one thing to do, and you can check that out. But this is how I double check things. So I'll go into my jobs directory, or I'll go into my creating a data set. I'll check out my path here, and then I'll make sure that this path is where I want my jobs stored. So in this case, you can see I've got like home, Ubuntu, and then digits 2, and here's where things are stored. Sometimes in previous digits installations, I'll have home, Ubuntu, and then I'll have .digits/jobs. And if that happens, then all I have to do is I'll go into my digits configuration, and the file is digits.cfg, I think, and it'll be in your. I go into my digits root. I go to where I have digits, like where you have your digits-dev server, and then within that digits root, there will be another digits directory, and usually my digits config file is within there. At least with digits 2, that's where it is. In digits 1, it might just be in your regular digits root directory. But if you have questions or have issues, definitely just reach out to us through the Google user group, and we'll help you locate that and find it. So there were some questions about, we got some more questions on the Jetson TK1, and of course, yes, you can do classification on Jetson TK1. And if you can also do cuDNN. So I'm sorry if I didn't mention that before. cuDNN is supported on the Jetson TK1. But you'll need to use, I think, CUDA 6.5 to use cuDNN, if I'm remembering things correctly. But there's also online documentation on that, and then you can reach out to us on the user group as well. Also, one thing with that too, I'm pretty sure that Jetson TK1 with cuDNN, you have to use cuDNN version 1. So we recently released cuDNN version 3, and that I don't believe that's supported on the Jetson TK1. You'll have to go to cuDNN version 1. But when you go to developer.nvidia.com and cuDNN, you can download it, and there will be options to select which cuDNN version you want to use for your Jetson. And the Jetson one will be, you'll see a list of options, and it'll flag which one's for the Jetson. So it should be pretty self-explanatory. But if you have questions, definitely reach out to us through the user group, or even on the GitHub site. There's also another email link that's provided through the deep learning course that you can use to reach out to us too. So someone had asked about a non-web-based interface plan for digits. And I think this happened during the last class. That's a really good question. I haven't heard of a non-web-based interface plan for digits. And it's a really interesting question. So maybe if this is something important to you, maybe for whatever reason, when you launch digits on your local machine, you're having a hard time doing localhost port 5000 or something like that. Engage with us and and ask us if it's possible and if there are ways to do it or what the best way is to do it. Also, if you're interested, just remember, guys, Digits is open source. So if you have ideas and you have an interest in making some modifications to Digits on your own, definitely welcome to do that. You can edit it yourself. That's one really great thing and advantage to having it open source is all the code is there, and you can make edits based on your needs if you're interested. We're always interested in, and I mentioned this before, and I'll mention it again. But this is a tool we use internally at NVIDIA, and we're definitely interested. We open sourced it to the community because we're interested in keeping it valuable to us and to others. We thought it would be valuable to others. So if there are things like this that you find important and you feel like you need, definitely engage with us. So there have been a couple more questions about data sets. So yes, you can support data sets. If you have a data set that can be represented in a linear array, like some type of signal, you can definitely ingest this. One thing somebody had asked about they asked about data sets with more than 3 color bands. So right now let's say you want to insert an image and it's grayscale or RGB, that's fine. But if you had something hyperspectral, right now it isn't supported. But if this is important to you and this is something that you could really use, engage with us on the Digits users group and talk to us about it, and then we'll see about potentially implementing it and how to do that, and potentially doing a pull request. So there are a lot of things that the team is working on, a lot of upgrades. They've got a lot of updates planned, and they're really busy trying to make as many improvements as they can. So I don't know, I can't make any promises to requests that people post on the Google group, but as we see more requests, it helps us prioritize things. It helps us decide, helps us make decisions about what's important, not only to ourselves internally, but also to our users, and we can sort of move things around based on needs. So there's just a couple things. Those are a couple things to think about. So somebody also asked about resizing many images at once. So Digits will handle resizing. If you're thinking about trying to resize your images like in some other fashion, or if you're trying to resize your image, if you're trying to resize your images outside of Digits for some other reason, I would just say that you could definitely use OpenCV. You can use Pillow. You can use ImageMagick. ImageMagick is relatively easy to use, and I use that a lot. Another thing that somebody had asked about was data augmentation. So right now, as far as data augmentation goes, you can mirror your images in Caffe, but then and you can also do center cropping in there, and that's it for augmentation. If you want to do other things, like I had talked, like in your lab, you'll notice that we inverted the images and made so every image has a copy of itself, but it's inverted. I did that through Pillow, I believe, or something, or maybe I used OpenCV, and that's one way to do it. So if you do that, if you want to do that type of augmentation, or if you want to do stretching, or you want to do some type of skewing or some type of affine transform, that right now is not supported in Digits, but you can definitely use Python, ImageMagick, and or you can use OpenCV, and you can use OpenCV, of course, through Python as well. OpenCV is a very versatile tool, and we don't have it in there right now. And one thing I found is, like, sometimes I need to augment my data, and sometimes I don't. So I would encourage you, when you think about doing augmentation, I usually think about augmenting my data when I realize, okay, I'm training. I've got a trained neural network, but my trained neural network isn't really a good representation of what I plan to classify when I deploy it, and I don't have a good way of getting a large amount of data that's similar to what I plan to classify when I deploy it. So I'll think about augmentation, and then I start thinking about, okay, well, what are things, what are features, what are characteristics and data that, and the information that want to use, the things I want to classify when I deploy my network, and what about that is not included in my training, and see if it's possible to do that type of augmentation. See if it's possible to apply something to that input data so that it's a better representation. So we're close to the end here. Time to wrap up. I just want to thank you guys for your time today, and I really appreciate you guys coming to. I really appreciate everybody participating in the last lecture, and I really thank you guys for those of you who have taken the hands-on lab, and for those of you that haven't had time, please do so. And I'd love to hear your feedback on it. The whole intention on the hands-on lab was to just show individuals interested in using digits how to get started, and to give you an idea for how and in what ways you can change your network and modify your network if you haven't done so before, and then ways to kind of just do check the changes in performance and approaches, simple things to do like that. Things that I did when I first got started using digits, and I found doing simple things like this helpful. So I really appreciate everyone's time today, and I'm going to wrap things up. If you have any more questions, please feel free to email us. If they're digit specific, feel free to reach out to us on the Google group. And then also, please come back next week. Next week we're going to have a lesson on. Oh, let me get to the series. So next week we'll have a getting started with the CAFE framework, and I think you guys will really like that. That'll be a really good lesson. And also we'll have Piano and Torch. So if you're interested in just experimenting with the frameworks and you kind of want to get started with the frameworks, these classes are a great intro how to use them, and then there will be hands-on labs associated with each one of them as well. Another thing to remember is that for those of you who don't have GPUs, or maybe you've got a system set up and you can't, for whatever reason, install these frameworks and test them out right now, you can use these hands-on labs, and you don't need a GPU. So you can use the hands-on labs to get you started and test out these frameworks without having a GPU, or without using a current machine that you have preoccupied with GPU installed. Thank you everyone for your time today. I really appreciate you participating, and definitely feel free to reach out to us with more questions.